Hello students, welcome to all of you in this video lectures. Here I am going to continue, going to start the new chapter which is vectors algebra, right? So in this video lectures I am going to explain some terms related to vector algebra. The first term is, what do you mean by a scalar? Scalars. The students, all of you got in physics that the quantities having only magnitude and no direction is called scalars. So a quantity having no direction and only magnitude is called a scalar, right? For example, mass, volume, density, right? These are the examples of a scalar, right? So students, what is a vector? What is a vector? A quantity having both magnitude as well as direction, right? A quantity having both magnitude and direction. For example, velocity, right? Velocity, acceleration, because this term having both magnitude and direction. So students, these are the definition of scalar and vectors. Now in this chapter we will discuss about the vector algebra. Now there are many types of vectors. Now we will discuss about the types of vectors. There are various types of vectors, so all of you should know these types. So students, first one is null vector. Null vector, or you can say zero vector. This is also called zero vector. The students, a vector whose magnitude is 0, right? A vector whose magnitude is 0 is called a null vector. A vector whose magnitude is 0, it is represented by zero vector, is called a null vector. Number 2, unit vector. So what is unit vector? A vector of unit length, right? A vector of unit length means magnitude is 1. A vector of unit length is called a unit vector, and it is defined as unit vector equal to vector A by magnitude of vector A. We can find the unit vector of a particular vector, that is unit vector parallel to vector A, which is A cap equal to vector A by magnitude of vector A. Third type is equal vectors. Equal vectors. The students, it is clear that two vectors are equal if they have equal magnitude and same direction. Okay, here equal magnitude, and same directions of two vectors. Right, are equal. Right, so here vector A equal to vector B, we can say, then their magnitude will be also same. The student, next one is number 4. Negative vectors. Negative vector is a vector having the same magnitude but opposite direction. Right? A vector having same magnitude but opposite direction is called negative vector. Right? So here the direction is opposite, that's why it is called negative vector. And next one is collinear vectors. Two vectors are which are parallel to the same line, irrespective of their magnitudes, are called collinear vectors. Okay, two vectors which are parallel to the same line, irrespective of their magnitude. Right, are called collinear vectors. So if A vector equal to lambda b vector plus minus, then we'll have magnitude of A vector equal to lambda into magnitude of B vector, then A and B are collinear, right? Students, next I'll discuss about triangle law of vectors. Triangle law of vectors you have got in physics. So here I'll explain you what is called a triangle law of vectors. If two non-zero vectors are represented by the two sides of a triangle taken in same order, then the resultant is given by closing side of the triangle in opposite order. For example, suppose this is a triangle, it is OA, OB, right, and this is AB. Now in this triangle law of vector states that OA plus AB vector, OA plus AB vector equal to OB vector. This law is called triangle law of vectors. OA plus AB, now this side is closed. It should be a closed figure, so we'll have this OA plus AB equal to OB. Now if direction of AB is changed, then it will be negative. Depends on the direction. We'll use this law, and this law is called triangle law of vectors. The students, next one is parallelogram law Suppose there is a parallelogram. This is on the diagonal A, B, C, D. AB plus BC will be equal to resultant AC. Now this will be AD plus DC will be equal to AC. So here in the triangle law, in a parallelogram we have, this is R resultant and R is equal to AB plus BC, right? And the magnitude of R will be equal to root over mod A square plus mod B square plus 2 into mod A into B cos theta. This is under root. This is the magnitude of the resultant, root over S square. I am writing again, root over mod A whole square plus mod B whole square plus 2 into A dot B cos theta. This is how we can find the resultant R, which is nothing but the diagonals of a parallelogram, the magnitude of diagonals or the resultant vector in law of parallelogram. So students, next I will discuss about the properties of vector addition. Properties of vector addition. Number 1, vector addition is commutative. Commutative. That means vector A plus vector B can be written as vector B plus vector A. Number 2, associative. Associative. This is properties of vector addition. So this is only in case of addition. So associative, vector A plus B plus C will be equal to A plus B plus vector C. Third vector is existence of additive identity. Additive identity. That means vector A plus 0 equal to 0 plus vector A. 0 vector is additive identity. Number 4, additive inverse. Vector A plus minus vector A will be equal to 0. Then minus A is called additive inverse of vector A. Properties of multiplication of vectors. Number 1, if m equal to 0, a scalar, then m a vector will be 0. The vector A should not be equal to 0. Number 2, m n a vector can be written as n m a vector, which is same as mn a vector, where m and n are scalars. Third one, vector addition is distributive over scalar addition, right? A vector m plus n can be distributed m a vector plus n a vector. Next is position vector. If a point O is fixed as origin in space or plane, and P is any point, then OP vector is called the position vector of P, with respect to origin O. I am repeating again. Position vector means if a point O is fixed as origin in space or plane and P is any point on that plane, then OP vector is defined to be the position vector of P with respect to O. The students, position vector can be found out with the help of a fixed point, and that fixed point is nothing but, we can say, origin, okay, in the space, and that OP vector is called the position vector of that point P with respect to O. So students, I am ending today's lecture where I have discussed few definitions of vector algebra. I hope all of you understood. Please go through it. If there is any doubt, you can contact me. Thank you very much.